Okay, for question 4 of the exam, part A says draw a state transition diagram. So part A, we know we're going to have the office and Parks and Recreation. Say office and Parks and Recreation. Office and plus 1. Okay. Each minute, we know that 20% of Parks and Rec watchers switch to the office. So we'll say 0.2. Recreation, skip to the office. We know that 11% of people watching The Office switched to Parks and Recreation. Which means 89% of people are still watching The Office. 80% of people are still watching. For part B, our system of equations is going to start with The Office and plus 1 is equal to, and what makes up The Office? Well, we know that 0.89% of viewers are still going to be watching Office after some time has passed, and we know that every minute 20% of Parks and Rec watchers switch to The Office. Now, Parks and Rec, we know that 11% of people watching The Office switched to watching the Parks and Recreation, and that after some amount of time, 80% of people are still watching Parks and Recreation. Okay. Part C says, using what we have learned, determine the number of viewers of each show after 10 minutes and after 20 minutes. Originally, when I first went about this problem, I was thinking more of the Leontief output model that we solved for x, where it was vector x equals A minus the identity matrix inverse times the demand vector. But after watching the video, I forgot about this formula that we use when we're given time. So vector x at time t is equal to matrix A multiplied by, or to the power of t, whatever t is, times x naught. Really quick, we're going to define x naught, which means the initial state vector x. In the problem, it says, assume the total number of viewers is fixed at 22,000, with 13,000 initially viewing The Office. If we have 13,000 viewing The Office, that means we have 9,000 viewing Parks and Rec. Part C wants to know the number of viewers after 10 minutes and after 20 minutes. using our equation of 10 n per t, our A matrix is going to be 0.89, 0.2, 0.11, 0.8. And this is going to be to the 10th power times x naught, which is 13,000 and 9,000. So at time 10 minutes, there's 14,164 office viewers, 7,836 Parks and Recreation viewers. Now for 20 minutes, we get our A matrix. To the 20th power, since we want viewers after 20 minutes. Times x naught. And we get that after 20 minutes, there is 14,193 office viewers, 7,807 Parks and Rec viewers. Lastly, Part D asks us to find the steady state. To go about this, I'm going to find the inverse of my A matrix, which is negative 0.11, 0.2, and negative 0.2. And I'm going to set the zero vector as my constants. And RREF, and we get 1, negative 2011, 0, 0, 0. This bottom row indicates that we have infinite map of solutions. Oops. Solutions. So, looking at our leading ones, looks like we have a leading one where the X is, or I guess where the office is. So this means that we're going to let P, let's see, which means that office equals 2011 C. P and equals C. So we know that ON has to equal 22,000. Now we plug in our values. So we have 2011 C equals 22,000. This C is like the same as saying 11 over 11. So we get 31 elevenths. C equals 22,000. Now we take the reciprocal of both sides to get rid of the fraction. And we get that C is equal to 7,807. 1.6. We were really, really close to the steady state with after 20 minutes of time, but it's gonna take a little bit longer to get there. So the steady state and we'll call it vector v is equal to 7806, which means this is 14,194.